My name is Alexis Madrigal. I'm a senior editor at The Atlantic and a lover of Earth observation. I started off with a little story. Probably the most famous Earth observation ever made is this photo that you may have seen of kind of like the whole Earth, this sort of big, glowing orb hanging in the blackness of space. And it actually didn't come around till Apollo 17 that we actually got to see that view of the Earth. And one of the reasons is there was a young guy named Stuart Brand, who some of you may know from the Whole Earth catalog. But at the time, he was kind of mid-60s, and he was a hippie, and he went around sending letters and handing out buttons saying, we want to see the whole Earth. We want to see this observation and see ourselves as one sort of community on the planet. And in fact, after NASA released that photo of the whole Earth, some historians actually credit it with being a major catalyst for the environmental movement. That it actually, that moment and releasing that thing was in fact transformative for the way that people thought about the Earth and their role within it, where there's no country boundaries, that we see it's all one biosphere that we're living on. But I'd like to think sometimes that if Stuart Brand were a young guy in our time now, if he were a sort of hard-nosed hippie in 2014, that he might call for something else. He might call actually for sort of the long Earth catalog. And what I mean is, I think the whole Earth is this beautiful thing that sort of almost like informs us of a kind of like secular spirituality around the Earth. What we need are these sort of focused and long-term observations, not just big data about the Earth, but the same parts of the Earth imaged by satellites time and time again, so that we actually see what change looks like. And we have with us Barbara Ryan. She spent her career, most of her career, at the United States Geological Survey, which has done some of the best of this kind of long Earth observation, creating these data catalogs. And she's been a big proponent of opening that data up so that people can actually use it and understand it. She's now, things with secretariat in it, I feel like I always put the words in the wrong order. But she's the director of the Group on Earth Observation Secretariat, which is a group that's trying to bring a bunch of different people who are observing the Earth from satellites and different kinds of sensors, all kind of into collaboration with each other. And I think if you think about the kinds of institutions that we're going to need in the 21st century when the kind of climactic baseline is changing and we're trying to understand what it is to live on a world where the climate is changing, this is exactly the kind of group that we need. So Barbara's going to kick us off with some slides. Then I'm going to ask her some questions, and then we're going to open it up and have a nice intimate discussion here. So Barbara?
Great. Thank you very much, Alexis, and a great introduction, because a couple of the points that Alexis just talked about, I'm going to come back and reinforce. So really, we are here today to talk about unleashing the power of Earth observations. For many of the talks that I've participated in as a listener all week, I can see linkages and connections where Earth observations could inform many of the policy discussions, and yet we've got some challenges, we in the Earth observation community. So whether it's the words we're using to tell the stories, I just don't see a good solid uptake of these assets into the policy debates that are occurring. And so hence our real excitement about being with here this week with Aspen's Idea Fest. So unleashing the power of Earth observations. Ironically, Alexis talked about this, one of the first images of the Earth from space, and really gave you this feeling of an entire planet. You can see with this shot down in the lower right-hand corner that shows Australia, you can see why people started coining it the blue marble or the blue planet, because of just the sheer volume of oceans and waters on the planet. But let's look at that water a little bit differently. If we assume that let's take all the water on the planet and put it in an orb or that this sphere, it would occupy that much space. So that's the globe, that one larger circle. is just indicative of all the water on the planet. If you look at the next smaller circle,
all the ice,
everything, frozen, solid, vaporous. If you look at the next smaller circle, not where the arrow is, but the one in between, is just the fresh water in and on the planet. And if you look at the very smallest circle right there, kind of in Georgia or wherever it is, that's only the fresh water that's in rivers and lakes. And so that's largely the water, with the exception of groundwater, of course, that we use to serve most of the drinking water supplies, the agricultural supplies of the world. So while that first image from space showed a really immense blue planet, it's a much more precious resource than I think that first image from space would indicate. So when we talk about Earth observations, what are they? They are those observations that we take from satellites that are circling the Earth or hovering over particular geographic areas. They may be Earth observations that are taken from balloons, or we happen to call them in situ measurements from one particular place. The sensor stays in a place and senses the parameters around it. It could be terrestrial observations, or it could be marine-based observations. So governments globally are investing tremendous resources in the establishment and development of these sensing systems. Yet many governments still sell the data that these sensors determine or contribute. And so our organization is advocating that if citizens, taxpayers, are in fact paying for the establishment of these sensors, then the data that is derived from those sensors should be released broadly and openly. If we look at just the United States investment in the last Landsat satellite, it was $850 million. And to charge citizens another $400 to get access to the data from a satellite they have already paid $850 million for is a travesty. So therein is our effort in unleashing the power that's tied up in these Earth observation sensors. Our organization looks at these functional areas: agriculture, biodiversity, climate, disasters, ecosystems, energy, health, water, and weather. And again, whether those observations of the Earth are from satellites, from atmosphere, from terrestrial sensors, or from marine sensors, we are interested in bringing all of the observations together in an integrated fashion so that you could start applying those observations to society's greatest problems. We've got some wonderful examples down in weather. You, as citizens, are now getting actually remarkable forecasts, 3-day, 5-day, 7-day forecasts of your weather here or anywhere else on the Earth. A lot of effort has gone into that, but how come we as citizens don't have those same kind of forecasts in each of these other areas? And how can we take the observations that were designed for one thematic area and apply them to the other areas? So if we just look at the Earth observation satellites, you're going to see a couple things here. You're going to see this outer ring of satellites. We call those geostationary satellites because they hover over one part of the Earth, and as the Earth rotates, the satellites rotate at the same time. So they are constantly taking pictures every 10, 15 minutes of the same place on the Earth. If you look at this inner ring of satellites, we call those polar orbiting satellites. And so they go generally north to south. And as the Earth rotates around the inside of that rotation, you can see that those polar orbiting satellites are now collecting data for the entire Earth. There are some blind spots at the North Pole and the South Pole, but the combination of those rapid images that come from the satellites, those geostationary satellites that only take images over one part of the Earth, combined with the polar orbiting satellites that take pictures of the entire Earth, must be integrated better than we are currently integrating them. Now those polar orbiting satellites, it may be 6 days, 8 days before that satellite comes back and observes that same spot on the Earth, which is the importance of bringing the information from both of those suites of satellites together. And again, the colors on this slide show that many governments have satellites in both geostationary orbit and polar orbiting satellites, polar orbiting orbits, and we are talking about ensuring the broad open sharing of data from all of those governments that are shown on this particular map. A story out of the Landsat satellite, because as I did work for the Geological Survey for most of my career, the first Landsat satellite was launched in 1972. The United States sold data for almost 40 years. The policy changed in 2008. You can see right here. So the data was sold at about $400 or $500 a scene when the federal government operated the satellite. The data was sold for $4,000 or $5,000 a scene when the private sector operated. Landsat's $4 and $5 in the mid 80s. And yet what we saw and what we were arguing to the administration at the time was that by selling this data, you are creating a barrier to its uptake. And this graph shows that. At the peak of data sales, the best data sales ever was 2001, 51 scenes a day were sold at $400 or $500 a scene. As soon as the data in 2008, as soon as the data policy changed, the usage jumped up by 2 orders of magnitude from 51 or 53 scenes a day, I can't see the number, up to 5,700 scenes a day of Landsat data are downloaded today since 2008. So the number's now close to 12 or 13 million scenes. It's 186 countries over the world. People are coming in and saying, before, when they came in and said, give me a Landsat scene over my area of interest, they are now coming in and saying, give me all 40 years of Landsat data over my particular area of interest. From an economic standpoint, while one government agency, happened to be mine at the time, was benefiting from the sale of those 51 scenes a day, it was substantial, it was $3 or $4 million a year, it was not a good investment for the federal government or the citizens of the United States. When you looked at who was buying those 51 scenes a day, number 1, other government agencies. Number 2, universities getting their money from the National Science Foundation. Number 3, contractors getting their money from the Defense Department. So we were just recycling federal money with every single transaction. And it wasn't until the Department of Agriculture changed their data from Landsat to an Indian satellite because they could get it cheaper that we were able to go back and say, talk about a failed US policy. And then in terms of building economic growth, we were briefing this slide about 6 or 7 months ago. Somebody in the audience said, from the private sector said, we fought you on this policy change because we were sure as soon as the federal government was going to be giving this data away broadly and freely, it was going to compete with our business. And he said, I can tell you I've added 125 jobs to my small consulting firm just to process Landsat data. So luckily, our arguments were right. We went back to the Office of Management and Budget and said those 125 jobs will deliver way more economic return to the economy of this country than the 51 or 53 scenes of Landsat sales that one federal agency benefited from. What's the data being used for? This happens to be a slide of the Iberian Peninsula. It looks at forest cover over the last 10 years. Green areas, there have been no change. Red areas are deforestation. Some blue or purple areas show reforestation. Hundreds of thousands of Landsat scenes went into generating this image. You would not have been able, no organization, no country would have been able to afford to do an analysis like this for the Iberian Peninsula, much less globally, until the release of that broad open data. So analyses like this were just not getting done before that data policy was changed. Let's look at a place closer to Earth. I think Alexis mentioned this. This happens to show land cover. Just look at the red, just look at the yellow and the green areas on this map, and key into this rectangle right here. What we're looking at is yellow in corn and green in soybeans from 2000 out to 2012. And what you saw, roughly soybeans, corn, soybeans, corn, soybeans. In 2005, the ethanol legislation went into effect, and that regular rotation of corn and soybeans was interrupted because of the subsidies that were given for corn production. And so from 2005 all the way out to 2012, when the subsidies were removed, only corn was planted. And so who would imagine that public policy decisions that we are making here on Earth can be observed from space with satellite information? And then I think one other thing that Alexis mentioned is just the importance of maintaining this data in archives so that you can go back and recreate these stories. I'd like to just end with one last story, and that is the issue of agriculture and how satellite images and Earth observations, because you still need ground-based observations, can inform this issue. If we look at monthly wheat prices over a 40, 50-year time frame, what you see is back in the 60s and 70s, we had a relatively stable pricing policy, and yet from about the 70s on, you saw tremendous spikes, largely due to droughts. And then certainly, although it's not shown here, by the time you get out to 2011, 2012, you're starting to see spikes on the order of 3 times what we had back in the early 60s and 70s. Clearly, the droughts that have been reported globally for 2012 are key issues, not only from a famine perspective, but from a health and welfare perspective. If we look at 2010, 2011, and 2012, this shows the inverse relationship, no surprise, between production forecasts at the beginning of the season, shown in red, and pricing forecasts shown in blue. So there's an inverse relationship. Production forecasts are high, prices are low. Conversely, when production forecasts are high, pricing is low. With the billions, if not trillions of dollars that are going into agriculture globally, one would think that in 2014 we could bring to agriculture what Earth observations have brought to weather observations over the last 40 or 50 years. How come in this day and age you get this kind of swing in production forecasts when in fact we know the climatic conditions? We should be able to do a better job of predicting production forecasts so that you could stabilize the prices associated with those forecasts, so that you could in fact create a more food secure world. So one effort, we happen to call it GeoGlam, our global agricultural monitoring effort. It is part of the G20 action plan on food price volatility. If you look at this map, this is just a snapshot of vegetation on one day, August 13th, 2012. And what this snapshot shows is the health of that vegetation on August 13th as compared to the 10-year average, its previous 10-year average. So it's an indicator, it's a relative indicator of the health today compared to the 10-year average. And what you see are clearly in the United States and Europe and in Russia, the droughts of the summer of 2012. You happen to see a different situation in Asia, which were healthier vegetation for the rice production forecasts in that part of the world. But the story here is that this is only achieved globally transparently with governments sharing this Earth observation information. So, in order to unleash the power of Earth observations, broad open data policies are needed for global monitoring and global transparency. We must leverage the investments that are being made by all countries. No one country has the resources to do this alone. Citizens globally deserve more. This young farmer deserves more. You deserve more. And we've got much of this information tied up in archives, and it's not being fed into the public policy decisions that it needs to be fed into. So thank you very much. And Alex, I'll turn it back to you.
Sure. I mean, I think it's so interesting as a journalist, what I end up using Earth observations for often is to essentially illustrate stories that are very difficult to illustrate. Like I think California is where I live, is in a horrible drought right now. And I wrote a bunch of stories about it, present data about it, but what these pictures, which are essentially visualizations of data, what they allow you to do is to just show, look, there's no snow in the Sierra Nevadas, right? Which means there's no water storage for California. And I think it's this combination that these images both have sort of a visceral, emotional impact around as images, as well as actually being data, right? They are,
right.
You can use the computing infrastructure that you guys have developed to turn that stuff into sort of actionable items.
Let me build on that example a little bit about the snow in the Sierra Nevadas, because I live in Geneva, Switzerland, and skiing is a big part of the tourist industry in Switzerland. And the University of Geneva has come in and for all the ski areas in Switzerland has essentially, based on historical trends, made some projections for future snow cover, and they've divided all the ski areas in Switzerland into 3 categories. Those at the very highest elevations where their industry will likely not be negatively impacted in the next 15 or 20 years. Those in the middle tier where they will see reduced number of skiing days, and then a lower tier where there will be no skiing by 2025 or 2030. And so that's the kind of analysis that Earth observations can help do with projection forecasts that really have substantial impacts on our economies.
So you mentioned that weather is the one area where we have a lot of success. And I don't know if anybody has tried to tap into weather tools recently, but there are so many tools that provide incredibly granular data. You can look at, there's all these, there's a series of maybe 12 or 15 different ways, models for forecasting weather in the country, in the world, in individual regions. And so when you go look now online, you can actually see what all the different projections say about the weather in your area. So why has weather been the one thing that's really worked in terms of unleashing these kinds of observations?
It's a wonderful question, because I think the whole weather field is just a fascinating subject. I'm not a meteorologist. My background was in geology and civil engineering, but I spent 4 years as the director of the WMO space program, and so I saw what Earth observations did for weather. It started 100 years ago. There was an international organization, the International Meteorological Organization, ultimately changed to WMO, the World Meteorological Organization, 50 or so years ago. So there were national standards that were harmonized. There were global standards that were harmonized, so weather services, national weather services around the world would comply with collecting data to a particular standard, sharing selected amounts of that data. And for me, if you participated in one of the panel sessions today about we've got to get out of this zero-sum game mentality, and whether it's organizations or whether it's countries really kind of working more collaboratively, at the peak of the Cold War, meteorologists in the United States and Russia were still technically exchanging data and scientific findings for the exchange of this information. So it's a phenomenal story that scientists, regardless of political differences, can come together. So national standards, the role of an international organization, broad open data sharing for selected data, the role of individual monitoring, individual modeling centers. When you talked about the projections that you happen to see from the European Center for Medium Rain Forecasting, or a Japanese center, or a United States center, they all perform differently under certain regimes. And so I happened to be back when the whole polar vortex issue was occurring here in the United States, and I was amazed because many of the weather channels were reporting better projections coming out of some of the European modeling centers than those here in the United States, because it was such an unusual circumstance. For you here in the United States.
Well, I think what makes it so significant is just that we've all grown up in a climate that hadn't been changing that much. I mean, it's changed a little bit over the last period of time, but people are anticipating much greater changes to come, and so you can't sort of rely on your intuition about what winter is going to be like, as we go over the next 80 years.
Alexis, let me add one more thing, because I think particularly for a conference like this where there's a fair amount of private sector investment in this conference, the other thing that came out of that weather story is there was acknowledgement that the government provided a certain amount or degree of just basic data, and then the private sector, whether it was the Weather Channel or some of the other channels, were asked to come in and innovate on that basic data. And so the innovation and the creativity actually occurred over on the private sector side, not on the government side. And I think, at least from the experience that I had in the United States in the early 2000s, is we started to confuse the role of the public sector and the role of the private sector. And so again, if we go back into this, get out of the zero-sum game mentality and the importance of collaboration between the public sector and the private sector, that is exactly a model that we need to continue to advance. Let's let governments around the world build these satellites, launch them, collect the data, but let's get it out there so that universities and the private sector can come in and build applications and services off that basic data.
So one of the interesting things that we've been tracking on the Atlantic is that there are a bunch of new satellite startups. There's a bunch of new private sector companies that want to launch or have launched different Earth imaging capabilities. And in fact, one of them, Skybox, was just bought for Google recently for, I think it was in the
$500 million.
$500 million, something like that. How do you feel about these new entrants? Because at least it's my guess that they're not going to be part of these kinds of open data consortia.
Yeah. A couple things. For me personally, I think actually for our entire organization, any additional attention to the importance of Earth observations is very important. In fact, again, taking one of the findings from the panel earlier today, PepsiCo announced that they were going into Egypt, I think, and creating a new business market. A week later, Coca-Cola had come in, and PepsiCo said, this is actually good. It'll present some problems down the road, but the fact that more investment has been brought to this part of the world is important. So I would say the same thing with these private satellite providers. In many instances, they are collecting much higher resolution data than what a lot of the government satellites collect. And so what the conversations that we are having with them is, even though your business model may still be to sell data, will you at least share your footprint, your global footprint, with us on where you have data, so that as users come into our information infrastructure, they can get free open access to all the government assets. If they want higher resolution data, they can see that it exists and be sent over to that private sector provider. And then just one last point, we are seeing, even in the private sector market, a recognition that it's very difficult for them to collect enough money on data sales alone to launch and build the next satellite. They themselves know they've got to move downstream into value-added products and services.
Well, and just in case you missed it, Google now owns a satellite company, which is in and of itself kind of a fascinating thing when you think about their mission to try and organize all the world's information. they want you to be able to Google the Earth or a section of the Earth. And they previously purchased data from other places. They previously done all this stuff. So you see companies that are in information technology recognizing the value of this data. A question about, I mean, the most striking example I think was the soybean corn example, because it's such a, like the public policy impact is so visible in this. And what occurs to me is that there's a reason that it's been hard to push these things into public policy, because this is sort of an objective quantitative measurement. And it seems to me in a lot of contentious public policy debates, people don't actually want there to be an arbiter of the truth.
Right.
So how do you, as sort of scientists who believe in factual reality, how do you actually engage with politicians to say, hey, we want to put your idea to the test?
Yeah.
And where do you insert yourself in that political process so that you're not coming crosswise with the senators in Iowa?
Mm-hmm. So while we are largely working at the international scene in many of our 90 member countries that are part of the Group on Earth Observations, they have national coordination mechanisms. So here in the United States, there is a US GEO. It's a virtual organization where NOAA and NASA and the US Geological Survey come together to talk about the sharing of information. But for me, it goes back to this other, another issue, I guess, that came out of one of the earlier talks today, that even the wealthiest in the United States would be doing better economically if the growth was a little bit slower and broader based. And so the same thing is happening here. I think when the G20 agricultural ministers came together and said, we would all benefit if we shared more of this information so that we could in fact see global transparency. So when the estimates from one particular country come out with their production forecasts, if there is global transparency for that, then other countries are not hedging so much on what that production forecast was from one country. And so again, look at the countries that are participating in this effort: Canada, China, the European Commission, France, Japan, Kazakhstan, India, Mexico, Russia, and the United States. To willingly get these countries to come together is really remarkable. And I think it just speaks to one more part about the Group on Earth Observations. We are not a UN organization. We have UN organizations, FAO, the Food and Agricultural Organization, as a participating organization, but countries will often willingly come together under more informal structures than under formal negotiated agreements. So what we are hoping is that we can prototype efforts like this, and at some point when it needs to be fed into a more formal structure, fine, do it, but let's prototype it early, where you don't need 194 countries. Usually, usually they do.
So I know that your organization is largely serves an integrative role, but I'm wondering if you had all the money in the world and you could launch whatever satellites you wanted, you could get whatever kind of Earth observations you wanted, what would you put up? Like, what are the capabilities we don't have that you feel would have the greatest impact if we did?
Yeah. Let's see, there are a couple international efforts that are going on. There's a program called the Development of the Essential Climate Variables. And so they've done a really good job articulating selected parameters for nations to get behind on the observation of the Earth of essential variables for climate. The number one and number two most needed data sets are soil moisture and precipitation. A fair number of countries are working on that. But quite honestly, when you look at the previous slide that I showed with the satellites that are in orbit, I can't at this juncture say that I would be advocating for more satellites. I think we first have to leverage the assets that we have on orbit and on the ground with broad open data sharing policies. And once you know what you've got, then fine, go forward and do a real good gap analysis. But I think it's a much simpler technical problem, a more challenging political problem to get governments to share data. But it's a much simpler technical problem to just, let's find out what's out there first.
Yeah. When you look at, the entire globe, and one thing that's so interesting about observing the Earth from space is like you're actually observing kind of land use change, generally speaking. So what are the kinds of things that we've learned from having satellites in space for 40 years, doing this kind of land use change observation?
Yeah. I didn't put the slides in this package, but we've got some wonderful images of just urban growth in Las Vegas. From 1972, I think, when the population was about 300,000, to maybe 2010 when it was 5 times that, 1.5 million. I don't even know the population of Las Vegas today. But you can see tremendous urban sprawl. You can see with that sprawl comes a demand for groundwater resources. There's a satellite resource that's called synthetic aperture radar, where you can continually pulse or sense a particular part of the Earth and see change in land surface. And so we have been able to detect subsidence over Las Vegas, just centimeter scale subsidence, but enough to crack your foundations because of groundwater extraction from the ground to support that increased population growth. If we look atmospherically, you may not know that the dust storms coming off the Sahara Desert are in fact affecting the health of coral reefs in the Caribbean. I think you know that the air pollution coming from Beijing right now is being sensed in the Pacific Northwest of the United States. So the practices in one part of the Earth have global impacts.
Although there's also the positive spin on that, which is that, right, the Sahara dust storms actually feed nutrients into the sort of Amazonian ecosystems, right? So there are also
right.
positives. Why don't we open it up for questions? It seems like there's probably some people who know some things in here. Sure. Oh, and
they would,
there's Mike.
They would like you to use the microphone.
Yeah.
So monitoring leads to this predictive modeling, leads to advocacy, and these are all the things that are very important. So when you brought up weather, I thought this is very interesting, because isn't it time for design to enter this world that you're talking about? Look at the weather. The weather is fun to watch. People want to know what to wear, right? And they look at it, and then now it's become this old-fashioned thing. Watching the weather is like watching entertainment.
Right.
So the kind of modeling you're showing, people don't want to see this stuff, right? But we need to. So isn't it time for design to get involved, where people actually say, wow, okay, this is kind of fun getting into this. What can we do? And this is great.
Yeah.
How do we make it cool?
Yeah, no, I think that's a wonderful comment, because I think one of the challenges, maybe I said this in the beginning, one of the challenges that we have are that we get tied up in the individual sensors and the models, and I don't think we are the best communicators of these stories, and so we need bridge people that can make that connection. We are, particularly in many of these areas, not weather, and you just showed this, we are largely pushing this technology out. There is still not enough of a pull, and what weather has been able to do is be able to create that pull for this information. We do have an applications, we're calling it an apathon, that's open until July 31st, where we are just asking young developers, any developer around the world, to come in, look at the information that we have in our infrastructure, and just come up with some unique applications that you wouldn't even think of. I don't wear a lot of makeup, but L'Oreal, I understand, brings a cloud cover, elevation data into your cell phone, so that as you go up in elevation or as the cloud cover changes, if you sign up for this particular app, they'll send you a text message and say you ought to be wearing sunscreen. And by the way, the closest place you can buy it is over here. But who would ever think, we certainly as scientists wouldn't think a cosmetic company would ever be developing an application, and we just need more of those applications for citizens.
Well, I can actually give you a great story. I wrote a piece for the Atlantic print magazine maybe 6 months ago or 9 months ago that actually, the Weather Channel sells weather data, and they have an entire data arm now that is tied in with real-time ad buying on the internet. It's tied in with targeting, like ad targeting on the internet, so that they say, okay, we know from our modeling that, there's this famous Walmart example, like 3 days before a hurricane, Pop-Tart sales go up. They basically can do that, but with a bunch of different types of weather data, so that you end up having these like crazy examples where it's like, obviously one would be selling umbrellas, like when the weather turns bad, or a few days before the weather turns bad. But one of the big findings that they had was that craft stores, apparently, their sales go through the roof when it looks like there's going to be a period of sustained rain. And the reason is you can't take the kids outside, so everyone goes to Michael's and like loads up on things. And so I think there's sort of two ways that you see this pull coming. I mean, one is just sort of the consumer-led, here's how we're going to use this. And the other is the sort of more B2B side, where these businesses figure out that if they add these certain types of data into their models for buying ads or buying, transforming their supply chain, so they buy, steel or wheat or whatever in different quantities than they otherwise would. I think you see that as like a major factor too, and maybe it requires slightly less design sensibility and more figuring out how to push that information into the business world so that people know how to use that information. Sure, right there.
So how has Google Earth helped or hurt or changed kind of the dynamics?
I wish I thought of that
especially
question.
From the demand side of, I sit on Google Earth and geek out all day, and I have no idea what I'm looking at, but it's, there's layers upon layers, but is that helping this dialogue?
Yeah, I would say absolutely. Again, for the same reason that any increased additional attention helps. I think when you think about what Google Earth has been able to do for connecting Earth observations with citizens, it's really remarkable. Now, it's largely a viewing mechanism. Right now, they're not moving downstream to a lot of predictive and forecasting capabilities, but I think it helps getting people reconnected with the landscape. There's a tremendous ethos, I think, with just the power of place, where you were born, where you live, where you die, and this connection has got to be reinforced, and I think Google Earth has helped with that. We are working with their Earth Engine people, because what they are doing is taking the entire Landsat archive, putting it up into the cloud, and then allowing innovators to come in and design around this information. And so for many federal agencies, like the Geological Survey, you would have never been able to afford to be able to host the entire Landsat archive in the cloud, but an organization like Google can do that.
So interesting. Such a good question.
Yeah, can you hear me? Yeah, another question in the back. I very much enjoyed your talk. But there's only so much you can glean from satellite data in terms of the functioning of ecosystems, the distribution of species, identifying different species, and their health. But there's this whole other set of data coming online having to do with the abundance and distributions of species, how well they're doing, physiological measurements. And so it seems as if there's a real big future in terms of connecting these various different data sources. And again, with satellites, it's fantastic to have all this information. I'm all for it. But I think to really say something about the functioning of ecosystems, it's going to require this additional layer of really connecting them with the on-the-ground measurements in terms of specific species and so on.
I absolutely agree. In fact, I maybe glossed over it. Earth observations is everything. It's not just satellite observations. It's ground-based, it's surface-based, it's atmospheric observations, and those absolutely need to be integrated more fully. From satellite observations, you can get good global coverage because we can't afford to put our in situ or our ground-based sensors everywhere, but you absolutely need those ground-based sensors because satellites aren't observing actual parameters. They're observing reflectance from vegetation. They're observing radiances or reflectances. Somehow you've got to be able to assign a physical parameter to that reflectance, and you only do that with in situ observations. So it ties down those satellite observations. And I wish I had put it in because we did just issue a new terrestrial ecosystems map for Africa. And it included both satellite observations and a lot of in situ observations to put that map together.
Can I ask you one question just before we continue the Q&A? Are there key capabilities that we currently have that are in danger because of funding cuts, or because just the satellites are aging out of use, or are we actually doing okay in terms of sort of maintaining the funding for our Earth observations?
Yeah, no, I think there are certainly challenges. If we look at just marine buoys, so these would be examples of what you just cited, in situ surface-based observations that will detect surface height, sea surface temperature. They plateaued. There was a design for I don't know how many thousands of these buoys globally back in the mid-2000s, and they plateaued at about 60% of the ultimate build-out. This was going to require all governments coming together to put additional sensors in the oceans, and we're only 60% of the way there. So we could probably go down domain by domain and select individual sensors like that. What we are trying to do internationally is, one, talk about the importance of these Earth observations so that governments will go back and reinvest in their observation systems, space-based or ground-based.
Sure.
Hi. I wonder if you have any connection with the power industry. And I'm thinking back to one of the first power stations, an anecdotal story I've read a number of times. They would understand what demand would be by the cloud cover. They'd have a guy watching, the clouds would come over, they'd shovel faster to make more power. And I think about it from the perspective where you have a lot of countries where the dominant source of their power is hydropower from glaciers that are melting and disappearing. And I wonder if there's an application, if you guys are already connected in that way, and also, solar power, wind power, they're heavily dependent on weather variables, if that's an area that you're getting involved with at all.
That's a great question.
So absolutely, there are absolutely applications. In fact, I feel that our entire energy societal area is really ripe for kind of this next decade. I think for me it's kind of palpable. I can feel that it's going to take off, but it's going to need stronger partnerships with the power industry. Right now we have governments, 90 governments that are part of the Group on Earth Observations. We have UN organizations and scientific associations. About a year ago, our governing body came and said, well, if you really want to influence the uptake of Earth observations in policy decisions, you've got to bring the private sector to the table. So in the energy area, we are just now starting the dialogue. We've got assets like a new global solar and wind atlas that has been generated globally, that we're trying to give more visibility to. And then obviously a lot of work is going on in Germany right now with their move towards predominantly solar energy, and they are a key contributor to the Group on Earth Observations.
And
I agree entirely.
I think the modeling, I think the power industry in general knows, I've written some about this. I was interviewing David Crane from NRG. It's like the largest power producer in the US. I think they know that they're going to a much more complicated system that needs more data to function properly. They know that there's going to be way more generators because there's going to be way more people with solar power. There's going to be more wind farms. And even the size of the average major power station peaked a long time ago. There was a period of time when people thought that there would essentially be these things called newplexes, which were going to be they'd put 5 gigawatt power stations all in one place. And instead, the energy future that we have now is one where there are more and more sources of energy that each have their own different kinds of load profiles and conditions under which they function best. And to tie all those things together, they need more and more data so they can understand the changes to the load on their system beyond this sort of, they always will show you the kind of load curve, right? Like going up at certain times. But if you think about that's like the lowest resolution way of thinking about all these people drawing power, all these people putting power into the system. And the smartest utility executives clearly know that they need to both understand the kind of baselines at these fine resolution timescales, and they need to understand like the changes that are occurring all the time.
Just maybe building on that just real quickly, the importance of integrating across the thematic areas, not just the space-based and the ground-based information, but across energy and water, is that one community's, the noise in one community may in fact be the signal in another community. And so we have examples where a particular community will throw out data because they think it's not relevant to the particular thing, and then what they realized, another community, biodiversity, will come in and say, well, wait a second, that just showed bird migration, not with, it was noise from an air traffic perspective, but the biodiversity community was quite interested in where those birds were going.
Bats
bats.
show up on radar a lot.
So the integration of information is essential.
Let's go with one last question. Yeah, sure.
Sorry, I don't want to double up here.
No.
And steal the last question, so are you guys the clearinghouse for this, or who is that? Because everything I'm hearing is it's similar to Mac, right? There's an app for that.
Yeah.
Well, your answer is there's a map for that.
Yeah.
But how do we? Who tells us it? Where is there an index? Is there?
Yeah. So a couple things. You can go to our website and you will see a portal where you can get where you will discover and access about 70 million Earth observation resources. You can search you can search geographically, you can search thematically, you can search by time. Show me all the data that was collected between between a particular period of time. That data is not resident in our infrastructure. It's with NASA and NOAA and the Geological Survey and the Chinese Meteorological Organization and the Indian Space Agency. It is distributed around the world with those agencies that have responsibility for the QA/QC procedures, for the archiving of that data, and if they agree to releasing it broadly and openly, we go in and develop something, an API called a Discovery and Access Broker. So our entire infrastructure is designed just to discover and then access that information.
That's great. Well, I think the only closing remark that I'll make is I just think it's important, like when we talk about the 20th century, we talk about the meteorological organizations. Those were these organizations and institutions that over time had developed into this incredibly valuable thing for the world and for the United States and for protecting people's lives. And I think that this type of Earth observation and the type of integration they do is a 21st century institution that we really need. So thank you, Barbara.
Great. Alex, thank you very much.
Thank you very much.